So let's see if we can define some vector arithmetic. Since we've defined a vector as an n-tuple whose components come from a field F, we can define the equality of vectors the same way we define the equality of n-tuples. The corresponding components must be equal. But because the components came from a field, then both addition and multiplication are defined for these components, and so we can define arithmetic operations as well. We'll define these operations component-wise. Given two vectors v with components v1 through vn, and u with components u1 through un, and some scalar a, we define a times v, the scalar multiple of v, to be the vector where every component of v is multiplied by a. We'll define v plus u, the sum of the two vectors v and u, to be the vectors whose components are the sum of the corresponding components of the vectors v and u. And finally, we'll define v minus u, the difference between the two vectors, to be the vector v plus -1 times the vector u. Because we can add scalar multiples of vectors, and because anything we do once we can do as many times as we'd like, we can form a linear combination of vectors, a sum of scalar multiples of vectors. So let's take a look at a few examples of scalar multiplication and vector addition. So we'll have two vectors u equal 3, 1, -2, 5, and v 2, 1, 1, -5. Given these vectors, we'll find u plus v, 3u, and u minus v. So remember, when we add two vectors, we're going to add them component-wise. The first component to the first component, the second to the second, and so on. So we can add these two vectors. We'll start by adding the first components together. 3 plus 2 is 5. We'll add the second components together. 1 plus 1 is 2. We'll add the third components. -2 plus 1 is -1. And finally, adding the fourth components together, 5 plus -5 is 0, which gives us the sum of the vector u plus v, which will be the vector 5, 2, -1, 0. What about the vector 3u? This is a scalar multiple, so checking our definition, we see that we want to multiply every component of our vector by the given scalar. So the vector 3u is going to be found by multiplying every component of the vector u by 3. So we'll multiply the first component by 3, that gives us 9. We'll multiply the second component by 3, that gives us 3. We'll multiply the third component by 3, that gives us -6, and we'll multiply the last component by 3, that gives us 15. And so our vector 3u is going to be 9, 3, -6, 15. Finally, our vector u minus v, by definition, the difference between two vectors is the first vector plus -1 times the second vector. So that means if I want to find u minus v, what I need to find is u plus -1 times v. So let's find -1 times v. And that's going to be the vector v with every component multiplied by -1. So that gives us the vector -2, -1, -1, 5. Now we'll add our vectors component-wise. The first component of u with the first component of -v, the second component of u with the second component of -v, the third components, and the fourth components. Performing the additions gives us our final vector u minus v, 1, 0, -3, 10.